Hello, welcome back. So we are continuing through chapter 2, which is a chapter on direct proofs. Of course, if you're going to learn about direct proofs, you have to prove something. So our focus has been on some introductory results from number theory. So we define what the integers are and said a couple basic facts about them. We defined even and odd integers, which was useful because that provided a lot of good practice for proving things directly. And then we defined last time this term divides. A number A can divide a number B. It's actually a generalization of the definition of an even number. A number is even if 2 divides it. So this is A divides it. So it's just, something else could divide it besides 2. And therefore, as you would expect, the definitions are very similar. Okay, so often in math, you have an idea, some sort of concept, and then you say, okay, we've proven something about this concept, we've developed a little bit, but in what other directions could this concept take us? So we have this idea of one thing dividing something else. Well, what if you have 2 things, and you have an integer c that divides both of them? So here's A, here's B, and c divides A, and c divides B. So this is interesting, okay? Where does that lead us? Well, first of all, that has a name. It's called a common divisor. If A, B, and C are integers, C divides each of them, then C, it's a divisor of A, it's a divisor of B, so it has a good name, a common divisor. So it's a common divisor of A and B. Now that concept alone, there's some interesting stuff there, but really the best stuff happens when you add one more layer to this concept and ask, what about the greatest common divisor? So the greatest common divisor of A and B is, well, I'm tempted to write the greatest common divisor of A and B is the greatest common divisor of A and B. It's a term that is basically self-defining. It exactly describes itself. What's that called? Onomatopoeias, like it sounds like itself or something. Well, that's kind of like what this is. But I'll give a different, a slightly more mathematical definition. Okay, so what is the greatest common divisor of A and B? That it is the largest. Also, think about the greatest, the biggest. But in terms of numbers, it's the largest integer, D, such that, so it's the largest thing that is a common divisor, such that D divides A and D divides B. That's what it means to be the greatest common divisor. It means you're both a common divisor and you're the greatest. Okay. By the way, common divisors, with one exception, always exist. So you can sort of think about that. Why do 2 integers, with one exception, always have a common divisor? A greatest common divisor, in fact. Why do they always have a greatest common divisor? Well, first of all, given any 2 integers, A and B, actually, before this, let me give you some notation. The notation for the greatest common divisor of A and B is written like this, GCD of A and B. Okay. So why do 2 integers always have a GCD? Well, first of all, given any 2 integers, there's always something that divides both of them. Can you think? What integer is always do I guarantee is going to divide A and B? 1. Yeah. So 1 divides A and 1 divides B. So, how could a GCD not exist? Well, if there were a pair of integers which had no common divisors, well, then certainly there's not a greatest among the common divisors. There's not any common divisors. But that's not going to be an issue because 1 always divides both of them. Okay. So 1 is always a common divisor, a CD. But why do we have a GCD? Well, it's, um, so the only okay, so if there's a common divisor, how could there not be a greatest? Well, maybe for a pair of integers, there's, larger and larger numbers. Okay, not only does 10 divide A and B, but 100 divides A and B, and 1,000, and a million, and a trillion, and there's no greatest because it just goes on forever, up and up and up. Could that happen? Well, again, no, because what does it mean to divide something? It means like how do you divide A? A divided by U has to be an integer, right? So, no, I mean, once the U's get above the A's, it's impossible. Now, there's one small thing that we have to be careful of. A could be negative. If A is -8, then there are things larger than it than divide it, like 1 or 2 or 4 or 8. Those all divide it, even though, So the way you want to think about it is that the largest divisor of A is the absolute value of A. So it's either A, if A is positive, the largest thing that could divide it is A itself. And if A is negative, then it's the opposite thing, the absolute value. Of course, if it's positive, then taking the absolute value doesn't change anything. If it's negative, it just makes it positive. So hopefully that makes sense. Likewise of B. So you know that the GCD of A and B has to be between, so I'll write GCD of A and B. So it's at least 1, right? Because 1's a common divisor, so the greatest is going to be bigger than that common divisor. And it has to be less than or equal to the absolute value of A. So there are only finitely many options. Remember, it is an integer, right? The GCDs, it's an integer C, it's an integer D. So it is an integer. So there are only finitely many options for what the GCD could be. If A is 8, or -8, same thing. The GCD would be either 1, 2, 3, 4, 5, 6, 7, or 8. Those are the only options for what the GCD could be. So yes, there's always going to be a greatest among a finite number of options. And by the way, of course, you could switch out absolute value of A for absolute value of B. Same thing. That'd be another way to bound what the GCD could be. Anyways, this is just a brief discussion. The GCD, with one exception, always exists because you always have a common divisor. So and there's a limit to how many common divisors you can have. So therefore, you have a finite number of common divisors. Find the largest one. Boom, there you go. You have a greatest common divisor. Now, I keep saying with one exception. Can you think, what is the one exception to everything I've been saying? There actually is one pair of integers, exactly one, for which no GCD exists. Yeah, so the GCD of 0 and 0. I just say they're integers. They could be negative, they could be positive, they could also be 0. If only one of them is 0, like the GCD of 0 and 8 is 8. Does 8 divide 0? Yeah. 0 divided by 8 equals 0. That's an integer. Does 8 divide 8? Yes, similar. So this is a common divisor of 0 and 8. And nothing bigger can be a common divisor because nothing larger than 8 would still be dividing the second one, 8. Okay, so 0 and another number does have a GCD, but 0 and 0, now equals nothing. There's nothing that it would equal. Because 10 divides 0 and divides 0. 100 divides both of them. A million divides both of them. A billion divides both of them. There's no limit. There's no upper limit. So there's no greatest because you can always go greater and everything divides it. So that's why that pair does not have a GCD. Okay, I think that's probably enough there. Let's actually do some examples. Okay, examples. GCD of 6 and 8. 6 and 8. What would this be? 2. 2 divides 6. 2 divides 8. Is there anything else that divides both of them? Well, okay, well, there are other things that divide both of them. So let's think about that. What are all the things that divide both 6 and 8? Can you think of them? So 1 divides both of them. 2 divides both of them. Is that it? -1 divides both of them, and -2 also divides both of them. So you got 2, -1, 1, and 2. Those are the 4 things that divide both of them. And among those 4, the greatest is 2. Okay. Good. GCD of 7 and 15. Why don't you do that one? Let me erase. Let me write 4 more. GCD of 12 and 8. Of 6 and -8. Of -5 and -20. And finally, GCD of 9 and 9. Okay. So, do you have an... Go and pause the video and try to come up with an answer for each of these. Okay, well, so among all the things that divide both of these, 12 and 8, which one's greatest? Is 1? No, you can get better. 2? No, you can get bigger. 4. Okay, yeah. 4 is the biggest thing that divides both of them. Between 6 and -8, 2. 2 divides both of them, and nothing larger can. 7 and 15 is 1. -5 and -20 is 5. And 9 and 9, 9. Okay, so there you go. Those are some examples right there. Okay, great. Well, I think we're gonna make this a short video. I check the length of this thing. Yeah, I'll stop here. Okay, so this will be a short video. So this is just a simple, not a simple, but it's an introductory concept, that of the greatest common divisor. And next time, in the next video, we will continue learning about GCDs by studying a very important theorem about them. It's called Bézout's identity. It's a good one and kind of surprising. So come back next time. It also involves a very challenging proof. And I'll give a little, I'll talk about why it's good to be challenged early on, even though it is challenging. Okay, I will see you next time.